161. And so it's 0.1 by 161 gives you 16.1 grams of zinc sulfate formed. And then the last thing here, running tight in space, is the volume of hydrogen at STP. Now this is another thing of your mole triangle. Your volume of gas, I would have put down here before, volume of gas at STP, standard temperature and pressure, because there is questions in which they say RTP, which is room temperature and pressure. Now standard temperature and pressure, standard temperature is taken at 0 degrees Celsius. Same rule applies. When we're leaving moles, we're multiplying. So in this case, at STP, you're multiplying by either 22.4 litres, or if you're changing that to centimetres cubed, 22,400 centimetres cubed. If you're going back to moles, you're dividing. So divide by 22.4 litres, or 22,400 centimetres cubed. They did say RTP, room temperature and pressure. It's taken at 24 litres, or 24,000 centimetres cubed, a higher temperature. So we know that the volume of the gas is greater. And so you calculate the volume of H2 at STP. We've got the number of moles of hydrogen, 0.1 moles. To get the volume, you multiply by 22.4 litres, or 22,400. It didn't specify in this case what it wanted, so just say go 22.4 litres and you get 2.24 litres. Yeah, so that's the first example in our notes though. We go on down. Well, look at the second one here. So in this one we can see that ammonium chloride is reacting with sodium hydroxide to form ammonia plus sodium chloride plus water. Before even looking at the calculation, look at the ratio. Sometimes they may ask you to balance it. In that case, it wouldn't be a bother to use. But the ratio here is 1 to 1 to 1 to 1 to 1. Once again, making life easier till we get a hang of these. So, again, I've summarised the information. They've given us two masses in grams. What do we always go back to in chemistry is the number of moles. So we've got 10.7 grams of ammonium chloride. So using our mole triangle, 10.7 grams. To go back to moles, you divide by the relative molecular mass. So thing you've got to do is work out the relative molecular mass of this. So it's made up of 1 nitrogen, 1 by 14, 4 hydrogens, and 1 chlorine. Now chlorine and copper, remember to keep in your halves. You add those up, 35.5 plus 18, 53.5. Going back to moles, you divide. It's 1/5, or I always prefer the decimals as long as it's not recurrent. 0.2 moles. Work out the number of moles of sodium hydroxide. Should be bigger. It says it's an excess, and remember we always work with the limiting. So 1 by 23 by 16, 40, so 10 divided by 40 is a quarter, so 0.25 moles. So again, we can see that our ammonium chloride is the limiting, and this is the one we're going to work with. Now once we know it's the limiting reactant, throw it back into the original equation using your ratio 1:1:1. So there's 0.2 moles of this, 0.2 moles of this, 0.2 moles of this, 0.2 moles throughout. If this was a 2, you'd double it. If this was a 3, you'd treble it. If it was a half, you'd half it. Find the mass of sodium chloride. So we've got the number of moles, which is 0.2. Over the mass. Again, you're leaving the center of the triangle, so you're multiplying. So you're multiplying by the relative molecular mass.